It's not working. Let's try it now. Yeah, now it's working.
Thank you.
Okay.
The other side.
You have this. And this.
The side right?
Yep.
I can do something wrong.
This side.
Okay.
No, it doesn't go in your ear. It just goes over your.
Okay.
Just like that.
Doesn't want to stay.
Okay. And if you have trouble, you can just grab it and hold it in your hand. Okay. Go for it.
Hello. Welcome to Second Saturday Stars. We're so excited to have everyone here today. My name is Sonya and I'm really excited to be giving today's presentation. I've been coming to this observatory since I was 8 years old, and I've been fascinated by space as long as I can remember. Now as a senior at Newtown High School, I've been volunteering here for nearly 4 years, ever since the summer after 8th grade, and I hope that following high school I can study astrophysics. One of my earliest dreams was to learn how to operate these telescopes, and now I not only get to use them, but I get to share that same sense of wonder with everyone else, and that's why I'm so excited to be the one being able to give this presentation tonight. So tonight we're going to be talking about human colonization on Mars. Our planet, with its shifting tectonic plates and vast shimmering oceans, it's always been our home. For millennia, humans have walked its surface, but today we face a new, almost impossible seeming question. Could we live and even thrive on another planet like Mars? To even begin answering a question like that, scientists bring up things like radiation shielding, in situ resource utilization, hypogravity-induced osteopenia, and planetary biocompatibility thresholds. But if I lost you anywhere in that last sentence, that's okay. Because those terms are real and they're important, but they're also not the entire point tonight. Because my goal isn't to bury you in acronyms or big words, but it's to take all of that complexity and translate it into something that's clear, digestible, and accessible to everyone. So to begin, we have a bunch of fun facts that I've collected. I conducted a survey, and these were some of the answers that I got. And it's clear that a lot of people already know a lot more than they think. We have answers ranging from they think that Mars might have water on it, or things that are more mythology themed, like they think that it's named after the Roman god of war. And then we also have answers that are very complicated, comparing the North Hemisphere to the Southern Hemisphere. And these are really big differences, but it also shows that everybody has at least 1 foot into this question. It's not something that we think is as niche as it is. So before we really begin, we want to talk about Mars, right? Because we're talking about that, going to Mars. So we have our solar system. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So we can see this order. We can see that Mars is one of the closest planets to us, which obviously makes it one of the best options. But why else? What makes Mars so special? There's actually a lot of Earthen similarities with Mars. So Mars also has polar ice caps, as you can see in this picture. And those not only pose physical similarities, but they also pose the ability to have similar types of resources in them as we do on here. It also affects the temperatures, and the tilt of Mars also has seasons. So much like Earth, while we have the 4 seasons, they may have different types, but it still functions on a similar system, so that as the year progresses, we have different types of weather, which would make adaptation to this new planet a little bit smoother. Additionally, the hours on Mars, the days are 24.6 hours long, which is extremely similar to 24 hours on Earth. So this also makes adaptability here a little bit easier because we don't have to deal with 48-hour days or 16-hour days. We can deal with just 0.6 extra hours. Now, temperatures. So this is where it gets a little bit interesting because Mars's temperature is very different than Earth. Obviously, we're all here today and we're able to survive both day and night with varying temperatures, and we all think it's a little bit too much when it's under 30 or over 80. Mars actually has an average temperature of around negative 80 degrees Fahrenheit, which we're going to think is really, really extreme. But the next closest planet, Venus, it also has a really crazy temperature, but instead of being negative 80, it's closer to 800. So then we move to Mercury, which actually ranges from 800 degrees Fahrenheit to around negative 290 degrees Fahrenheit. So if we compare Mars and Mercury and Venus, Mars is clearly a planet where we can adapt to this temperature a little bit easier without having to make extreme temperature adjustments. Then we have the atmosphere. So as humans, we need to be able to breathe oxygen, and it's going to be a little bit difficult for us to be able to artificially create that from other things that we have on the planet. Mars isn't completely ideal for this, but it has an atmosphere that makes it a little bit more acceptable. It has actually 95% carbon dioxide in its atmosphere, which makes it a little bit difficult to deal with, but compared to planets that have little to no atmosphere at all, it's definitely one of the most ideal. And then we have research. So if we're going to go to Mars, it's going to take a lot of research. And one of the things we're going to want to research is cosmic radiation. So what is that? It includes X-rays and gamma rays. And these are things which affect a lot of different parts of life, because X-rays we use kind of in medical fields, and we use gamma rays and other things. But going to space is going to result in changes in a lot of these, and going to and coming in, we're going to have to figure out how to adjust to be able to make sure our lives are okay. Then we also have entry, descent, and landing techniques. Now, in history, we've used a lot of technology and a lot of research to be able to figure out that landing in the water is really, really great. And I have a picture here of the Apollo 11 capsule coming down, and we can see the people coming out. This is one of the best landing techniques that we have. But we can't use that on Mars, so we're going to have to figure out another way. We're also going to have to use settlement protection, so we're going to have to build a little bit of shelter to make sure that the extreme winds, temperature, and things like that don't affect us when we're trying to live there. And we also have life-fostering conditions such as magnetic fields. So these magnetic fields are what actually protect the planet from incoming asteroids and things like that that would otherwise threaten the stability of all life there. So Mars has a lesser magnetic field, which we'll get into a little bit later, but that's another thing we're going to have to research and make sure that fits us well. And then we have technology, training, and cost. So if we were going to go to Mars, as of now, the most likely thing we'd be using is the Space Launch System, which looks something like this. It's a very long-shaped space shuttle, which would be able to carry a lot of supplies and people. And in addition to this, we have the Orion spacecraft, which is what would likely be carrying the actual people within the Space Launch System. Then we also have astronaut risks. So during traveling on Mars, there's going to be a lot of different risks that these astronauts are going to unfortunately have to face. And these include all that radiation while they're traveling and on Mars. And they also risk, while traveling, accidentally maybe getting wrapped in the gravity field of another planet, or running out of fuel, or not having enough supplies to make it from Earth to Mars adequately. So we would have to take that into account when we're paying for technology and training these people that are going to be the first newcomers on a new home. We also have in situ resource utilization. So this actually reduced costs, and I have a little bit of a diagram here. So we can take basic things like water, ice, carbon dioxide, and energy, and transfer them into things that are a little bit easier. So we can use things like oxygen production, water extraction, and turn them into energies and fuels that will launch rockets to go back home, launch rockets to complete missions with more supplies, and things such as that. Then we also have billions of dollars that is going to be spent. But this doesn't all have to be public, this doesn't all have to be private. We can have a collaboration between things like, for example, SpaceX and NASA. We can have collaborations that help make sure that the billions of dollars aren't directly from the government, but they're also not directly just from one person. And then we have adaptations. So lesser gravity on Mars is going to mean that we're going to suffer from muscle and bone atrophy, which is when, from non-use, they become weaker, smaller, less usable, and things like that, which would affect both muscle and bone, which makes it harder to move around. And while it may be okay while we're on Mars, if we ever hope to come back to Earth while being there for a long time, that's going to be a struggle we're unfortunately going to have to deal with. Then we come upon terraforming, which is what this artistic representation is of. So we would be transforming the surface of Mars from its very plain looking right now, orangey red surface to something that we would like to call home. So we would add plants if possible. We'd add shelters, potentially fake water sources, and things like that. But then we'd have to take into account environmental implications, which is another aspect of the research we'd have to study. And then we have the loss of the magnetic shield. Loss of the magnetic shield, which would affect the protection of Mars, like I've stated earlier. So if we lose the magnetic shield, we're also going to be under threat of incoming asteroids and things like that we're going to have to build something to protect us from. And lastly, we have energy sources. So here on Earth, we use energy like solar, water, and things like that, but there we'd have to use different things, which is what I'm going to build on in a second. So the next topic we have is the ethics of it. So who would get to colonize and what would the diversity be? So when we're talking about this, we would definitely want to talk about how we're going to choose who's going to come, right? Because that's something that we want to make sure is going to be okay. So to get a large population, you're going to need many thousands of people. So they can't be just astronauts. So that would have to be just the first couple missions, and then we can move on from there. From there, we can talk about Martian government and the Outer Space Treaty. So we wouldn't want the Martian government to be completely by one country. So if we were to get there first, the USA, we wouldn't want it to be completely controlled by the USA, because that would mean that it's not fair to the rest of the countries, and it would become another Earth where political complications could lead to us not wanting to be there anymore. So then we have things like the Outer Space Treaty, which actually prevents specific countries from taking control of celestial bodies. And then there's future generations, which would be affected by cosmic radiation, which is what this picture is of. So we have the magnetic shield around Earth, that little blue shield around it, which prevents us from getting affected by cosmic radiation. But on Mars, unfortunately, this would not be the case, and we'd be affected, which could prevent future generations from being possible. And then on the human culture, there's the carrying capacity, which is what this diagram is of. So as time increases, the number of people that a certain area can hold increases as well until we reach carrying capacity. And at which point, we start being able to not be able to take care of the people that are living on the planet. By making Mars a second home, we open this carrying capacity to a lot more people. And we make it so that population doesn't have to be restricted, and there's no more worries of overcrowding, overpopulation, and things like that, which cause such an issue in today's world. And then we have resources. So we would definitely need water, but we can use things like clathrites and recycling to get that. Then we have oxygen. And oxygen we're going to need, but like I said, the environment is actually 95% carbon dioxide with actually 0.13% oxygen on Mars. So we need to artificially produce that, as we would need to with food. So we can bring fresh and packaged things, but we can also bring things that are going to be planted and grown from Mars. So this is an example. This is from The Martian, which is a movie I'm not sure if any of you know. And it's depicting the character planting potatoes on Mars. So while this may not be a completely accurate representation, it's definitely a representation of an option that we have. And then we also have energy sources. So we can use things like nuclear fission instead of solar, because these are more sustainable on a planet like Mars. And then we have shelters. So we'd have to get a lot of shelter materials to be able to protect us from everything that I've been speaking about. And we would build those shelters out of materials such as clay, quartz, and regolith, which is an example of what I have here. It's just fine red powder, which contains a lot of minerals, which is extremely helpful for being able to be on Mars. And this, we also have rare earth elements, which we find here, and we'd also need to be able to make sure that we have a couple of them on Mars, and if not, be able to look for them or bring them with us. And then we have zeolites, which should be used for LEDs and batteries, because they're not a necessity, but we use batteries and lights in everyday life, and if we're going to survive the darkness on Mars, we definitely need these LEDs as well. And just kind of building on that, I've conducted a survey to be able to complete this presentation, and this is a series of bar graphs showing the percentage of people that found each of these items absolutely essential to survival. And that's where it becomes really complicated, but also really exciting, because you can see a large majority of people think water is completely necessary, which of course it is, as is food. But a lot of people don't think things like entertainment, law and order, things like that aren't as important. They are. Because if we stand by ourselves on Mars, we need something to keep us going. We can't go by ourselves in isolation. It's a proven fact. So entertainment is something that we would definitely need. Law and order would make sure that the government, that whatever we establish would be okay and safe. Things like shelter, communication, those are things which are completely necessary. So we can see that some people see what we need to do, some people aren't aware yet. And that's kind of why information like this is really necessary to share with everybody, because this is something that's real. This is something that could affect us in very few years in the future, and if we're not aware of everything that's going to take, we're not educated on our own futures. So kind of to summarize, Mars is definitely the most promising candidate for human interplanetary settlement. A successful mission will require extensive research across every phase of the journey, but is completely doable with the proper resources and attention. The technology, training, resources, and funding needed will be vast and complex, but it's completely doable with everything that we've used. We've gone to the moon, we've sent probes out, we have the capabilities. Long-term survival will depend on engineered adaptations, but again, we've adapted to the most extreme climates here on Earth. We can bring that there too. And colonizing Mars raises significant ethical challenges, but it also provides solutions to things that have been completely changing our lives for hundreds of years. So, in conclusion, moving to Mars is something that we can't do tomorrow. It's going to take a lot of work, it's going to take a lot of time, a lot of energy. But making sure that we understand what's going on, we understand the process, we understand what goes into it, that's something that we need to do. And I'm hoping that this presentation started to educate everyone in the audience as to where we're going with this. And I thank you for your time, and I encourage any questions. Thank you.
Question.
Sure.
You mentioned the average temperature is -80, I think you said.
Um,
Do you know the extremes? Hot, cold?
I don't know the extremes of like the hottest and the coldest that it gets on Mars. I do know that as the average is a little bit easier to deal with and adapt to than things like Mercury, where it's ranging by hundreds of degrees.
Nicely done.
Thank you. Yeah.
Do you or does anyone here know how long does it take to get to Mars with our current level of technology when we send probes? How long does it take a probe to get to Mars?
So I'm not sure of the exact number that it takes to get to Mars using a probe. Maybe someone here does. I just know that the time would be definitely different because we need people and we'd have to move at a slower pace to avoid damage. Okay, thank you again so much for your time.
That was great.